Good morning, everybody. We are here in another live coding session. Don't forget to smile. Even if you're not feeling like doing so. Yeah. Uh, so here this our recapitulation from yesterday. What we're missing. Uh, uh, Remember, we ended saying the solution, the official answer. And the guy, the author was putting this reverse, which we mentioned, but we were thinking that reverse we will be here, so we didn't do it. The reverse should be here, but then the author mentions right. He's right. That reverse is implemented in terms of fold left. So this is like, as he said, some sort of a trick. So, let's move on. Uh, yeah, exercise 3.14 for today. And yeah, by the way, we get the problem, the description right. It's, okay, so the only missing part was the reverse. Yeah. We copy because they are providing for this one the type signature. Implement append in terms of either. Okay, either you get to choose fold left or fold right instead of structural. This is something structural recursion. Where is it? Okay. um, okay, we have like, where do we put, where can we place this? Let's do it over here below this one. Paste the thing. A1, A2. I will assume they want to append A2 to A1 and not A1 to A2, right? This is mm, someone will say obvious, but I need to ask everything, question everything. Okay, we get to choose if we want to use fold left or fold right. But since we have the experience from yesterday, you know that now you're pretty sure that one fold gives you the list in reverse order, and the other one, fold right, gives you the list in the same order. The only downside for fold right is that it is not stack safe. And but if you implement the fold right using fold left, you get the stack safe version. So let's get started. How do we start? Well, you have to use one of these. I will choose fold right. Fold right accepts the list, any list, and an accumulator and a function. Let's write our expectations our expectations, append, and we will pass this. Mm, I think we can get rid of this. I'm sure if you are seeing. So in here we expect to be 1, 2, 3, 4, 5, 6. Okay. Well, let's start with this and then test the corner cases about the lists being empty. All right, you want to append the second one, A2, to the first one, to the first list, which is A1. And you need to think what will be the accumulator. If you remember, there was an exercise 3.8 in which mm, if you pass a list to fold right and an accumulator of empty list, you get the same list. We will use that idea. So the accumulator will be A2 and our list will be A1 and our function will be this, and this should do it. Hopefully, as you were saying, there's always something, and we and we got our thing here. There's always something, and we get to solve this uh, and okay, here what happened? Payon, my list. There is another append over here. Apply, fold right, fold left, fold right, fold left, or something. There's append, and I think we're closing. Yes. So it's not about parentheses. Well, two things. In here we have this, which is, for me, this doesn't make any sense. But now, you see the problem, right? Again, we copied the signature blindly, but we have our my list, our data type, because we wanted to be very explicit that it was our list. I suppose that will do it. No, sorry for my eyes are kind of well, at least we got rid of this error. Now we have one error to go. A2 required a list A. Okay, other missing. Hopefully you're seeing this. It was list and now it is my list. Hopefully you got to see that. And look at this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yay! Now the corner cases. Let's see how much. 10 minutes. The corner cases. How can we test? Let's copy this. And I want to make sure that you got, you know about what's going on here. Take take the exercise 3.8 as your base of reasoning because you are working with two lists, and in 3.8 you were passing a nil and you get this list. Now you get to pass this accumulator, the second list, so it will stay fixed, static, fixed, and the other list will be arriving. As an exercise, you can do this with a fold left. Can we pass a nil here? Yes. 1, 2, 3. Nothing's got appended. Again, 1, 2, 3. Now think about this nil. Nil. No, nothing. Well, nothing. An empty list. Okay. A1, and you have a non-empty list. A2. Pass for right will say. And you give me nothing, then your accumulator is the answer. Accumulator. Accumulator. And in here, you give me nothing in second place. In the well, this will qualifies as the exercise 3.8, and that will be for today, guys. Hopefully you get something if you're seeing this in the future and you are like struggling. I don't think that will be the case because, well, the probabilities by below down, you know, because probably 10 years from now, people will be learning a very different way. Uh, watching some guy from the past solving these problems, maybe this artificial intelligence that I refer to them as method of computation will evolve. Sorry. And yeah, I do have in mind a series. Well, not a series. It's a story about a place about I was about the things I just said about how the future, imagining the future, some sort of imagination exercise uh, about this place in the future, and it will be delivered by animations. They are very expensive. I'm not sure, but the story will be delivered whether by text or by some static images and text. But I invite you to take a look at the channel. It will be, in my opinion, a very good, you know, pastime, entertainment. So 15 minutes. Thank you very much. See you next time. By the way, I probably take some days because I want to tackle some other exercises that I have pending. So maybe I will pause this for some days. Thank you very much and see you very later. For now, have a nice day.